Welcome to Tech at Lunch, the podcast that satisfies your hunger for all things tech while you enjoy your midday meal. So grab your sandwich, tune in, and let's dig in.
Hello, I'm Nick.
Hey, I'm John.
And, this week we're going to kind of keep up with our, the series that we started about 2 weeks ago. Sorry we didn't do one last week. Football called, and
Let them know.
it was time to go watch a good Penn State win. Home win against West Virginia. Packed crowd, 110,000 people. If you don't know, Penn State does have one heck of additive manufacturing program. And I'm sure we'll get into that eventually. But that is definitely one that, if you're going to go find an engineering program to do for additive manufacturing, you definitely go take a look at them and, give them a shout. But, we don't have Ed with us today. He had some issues that popped up. But, we also want to let everybody know, because I know John did this last time, is gotten to the point of go check us out over there at Vulcanar 3D and printedheritage.com. Go check us out over there. We got some stuff going on, custom lithophanes and the works. So with that brings me to this week's topic. So we talked about consumables and sustainability last week for nozzles, beds, and tubes. So this week we're going to talk about the consumables and the sustainability for extruders.
Yeah. I mean, we got into a lot of the detail on single-use things. Of course, consumables most of the time are going to be your single-use things. So that's why we brought up sustainability. But before I go too deep, I mean, I think we need to kind of set a base layer, right? A base understanding. So I mean, extruder in the name makes sense. You're extruding something. A lot of people, anyone who's worked with AutoCAD or any of the CAD programming, applications, they know when you extrude something, you're bringing something to life. You're giving it depth. You're giving it some shape and form. So it's the similar idea. You're extruding out from a hot end, whatever your filament might be, whatever your medium is. So I mean, that's the most simple I could probably put it. Is it's bringing your plastic in and pushing it through the hot end to make it form into whatever your file, your STL is that you've submitted. Yeah. But yeah, at the end of the day, you got to start somewhere, right?
Right. So, and think about a tube of toothpaste.
Yeah, exactly.
Technically, that or super glue.
You're the force that you're squeezing on that bottle or that container is forcing the whatever medium to like toothpaste to come out of the tube there, and that's almost exactly the idea that we are using in 3D printing. Of course, it's a lot more focused, I would say, a lot more precise. You have a nozzle. We talked about nozzles our last podcast episode, where you can have a diameter of the exit of that nozzle 0.4. I think you use 0.6, right, Nick?
Mm-hmm. Yeah.
Maybe not on everything, but for the most part, a lot of people standard base nozzle comes in 0.4, so that's probably what you're using, and that's millimeter, of course.
Yeah, that's what I have on the Voron. Yeah.
Yeah. See, I mean, so it becomes why does it have to be like that? And to me, it makes sense because if I have a smaller diameter of my nozzle that my extruder is pushing the hot plastic through, I have a little bit more control on the detail of the print. I have a little bit more control on some of the, let's say, thinner walls and supports and stuff. However, I have a bit of a problem with anything that's that's larger in scale, right? So the thicker your, let's say, your layers are, then that can also directly affect the quality of your print, the integrity of your print. So I think that not only you need to think about the nozzle when you're thinking about your extruder, you need to think about flow rate.
Right, exactly.
Right?
Now, it's like you don't want to go to a 0.8 and think that, oh great, we'll be able to extrude this,
Yeah.
at a decent rate. You're not going to. It's going to flow through there through melted butter.
Yeah. Exactly. I mean, what do you like? Honestly, if you don't do it, if you don't control your flow, then you're gonna have inconsistencies, and that's where your artifacting will pop up, and that's where your layer shifts will happen because you've got excess filament here or less filament there. You know,
And
what do you think?
and if you think about it, also if your nozzle is too small and you are over extruding, through your extruder, you're also going to get a lot of, say, back pressure, and next thing you know, you're going to be shooting filament out your hot end. Seen that
Heat
before.
creep, right?
Yeah.
Right. I
But
mean,
the thing is like, even if you think about it, a 0.2 is great for certain things with enough speed behind it.
yeah, I think also it depends on the size of your entire, like if you're doing 0.2 and you've got a 300 millimeter by 300 millimeter bed, um, the smaller your nozzle's diameter there, the longer it takes to print. So if you have a benchy that takes an hour to print at 0.4 nozzle, you take it to 0.2, it's going to have twice the detail. It's going to take twice as long.
Right.
Because it's so much thinner. It has to be able to put the same amount of plastic. It can't do it in the same speed.
Exactly. And the thing is like you mentioned, nozzle size is dependent upon printer size. And the thing is that goes along with your extruder too. What is your flow rate? Your flow rate should be, kind of tuned to the size of the printer. Because larger the printer, like mine, I have a 350 by 350 by 350, but I also have an Ender 5 that you have to tune your flow rates for, those type of, events. What are you printing on them? How are they being used? Also, what material? I don't think people realize that the extruder type or what an extruder is directly also tied to the material that you're pushing through it.
Mm-hmm.
Because we've all been there. I know I really haven't messed with TPU all that much, but you put that, glue type TPU through there, and you better, pray to, whatever you're praying to, that you've got, at least a decent extruder behind it.
Add a way to be PC.
Yeah.
There you go. But no, you're right. I mean, some of us prayed up Joseph Prusa, right?
Yep,
So,
exactly.
But no, but seriously, I think that you make a great point. Like, I don't to kind of compare if someone doesn't know or use TPU. It's a very rubbery substance. If you've ever tried to force like a rubber band through like a I don't know, a hole the size of like a shoelace hole or something like that, just like a keyhole size. If you've ever tried to shove something that has that much friction on it, you're not going to have a good time. And that's the biggest problem with some of the extruders, because you compare a push or a pull system, and what I mean by that is your push system is your Bowden tube. It's got an external motor, stepper motor that has maybe one or two gears on it that's pulling in your filament and pushing it through the hot end. So that's a pusher. There's a puller, which is more of a direct feed or a direct drive, which is directly on the hot end. You don't need a Bowden tube to transfer from the extruder to the hot end. It's just directly through. Well, I guess you have a small Bowden tube there.
Mm-hmm.
Depends on which ones you're using. But it's definitely not the same amount of Bowden tube, and it's all in one compact unit. In my eyes, a lot of those are usually dual gear itself, and if they're pulling, you'll find that pulling something through is much easier than trying to push it through, especially if it's got what is it, our differences are like 0.001 of a dimensional accuracy, right?
Mm-hmm.
So it's really really finite differences. Like your filament diameter is 1.75 millimeter. If you have a Bowden tube that is too tight on that, you end up
mangling it.
like, yeah, you either it gets stuck, you won't push it through, or you'll have a clog. And that's the same thing with if you're pushing it through too much, like through a small nozzle, you'll get a clog. You'll have heat heat creep up the hot end, and then you're gonna have to take that whole thing apart to be able to get any more filament through again, because you've just melted plastic perfectly into the inside of it. So I mean, direct drive is the way to go. Bowden tube is not bad. It definitely is a beginner, but
now
dear God, use dual gear.
I'll have to ask this question, because I've used both. I do prefer, direct drive. Between direct drive and Bowden, okay, we have our opinions, and I think both of our opinions kind of align with each other. But would you think that a direct drive extruder would be considered would be considered beginner friendly?
Ooh, I would say more intermediate. I would not say start off with that. The reason being, trying to first learn how to feed your extruder when you first put a new filament into it. If you don't know exactly kind of what you're doing, it can kind of tend to get caught, turned, bent, pulled some way, and then snapping, and then you get plastic stuck in there, and it's not as easy. You have to take it apart again, try it one more time, and it gets frustrating. And if you're anything like me, if you do something 4 or 5 times and the same thing happens, I get a little bit upset, frustrated. I have to set it down and take a walk, think about it, come back and take it from a different angle. So for me, if I got a direct drive when I first started, it would be sitting down, and it would be in the corner still kind of waiting for me to put it in there if I got any type of had any type of struggle the first time putting it in, as opposed to having the one that's defaulted, where I clearly understand there's little resistance on that gear where the stepper is. Initially, I have an Ender 3. That's where I first started, and that's the easiest thing in the world to understand. You need to cut it at a 45-degree angle so it feeds through, so that the gear's teeth can grab it at a certain spot and then push it through or pull it through. I wouldn't have understood that as much if I had just went straight into a direct drive.
Which is kind of funny, because I kind of agree with you. I think start simple, work your way to the more advanced, printers. Because, if you can understand the simple stuff, you can master the more complicated environment. And, I'll say this, the Voron environment is a completely different animal than most other direct drive printers, because of the space from the spool holder to the nozzle itself, which I kind of see as an issue. The distance is kind of a pain in the butt, because it's not directly on top of the printer, directly on top of the extruder. Right. You do have some distance to overcome when you're feeding it and stuff like that. So, for me, I agree with you. I think that you need to start out with a Bowden system. I think it makes you understand the process better, understands the technology better, and really gets involved in that. And also, the thing is if you're talking about sustainability, those Bowden tube systems, like the Enders, are easier to maintain and find parts for. If you are to start with a direct drive system, it's all or nothing when you go to replace something.
Yeah, it's like you might even have to replace your hot end, which will double up what you have to replace. It's even more money.
Right, and which now makes me wonder. And I know you and me haven't touched on this conversation all too much. My question is, because we are talking about the sustainability of this thing, and I start to think that a lot of people are moving away from Bowden fed systems and going to direct drive. I've seen a lot of the new printers coming out for new people, for beginners, going direct drive.
Yeah, you know what? And I have noticed that most of those are Core XY.
Yeah.
So it's I want to circle back on the boron topic that you were talking about. It's almost like you need a Bowden tube between your hot end direct drive extruder and then your filament spool.
I do.
It's kind of like you have the best of both worlds there.
Yeah.
So but that's the intent though, because like if you think about, you're printing PETG or ABS, right?
Yeah.
You don't necessarily need to cool that or dry that filament, I should say, as it's coming in. But if you get into filaments like ASA, like PEEK, like some of the carbon fiber, like polycarbonates, like those things that need to be dried consistently. They can't sit on an open spool out in the open, like out and about, because they'll consume air, or they're, what is it,
Yeah, hydroscopic.
hydroscopic, that's what it is. They absorb water out of the atmosphere, so they that's why you need to dry the filament. But if you have a filament dryer, you're probably going to need a Bowden tube from there to your direct drive. I will say that.
Mm.
And the worst part is it doesn't hurt anything, besides it just protects the filament a little bit longer, so
Yeah.
it should keep that moisture out better.
Now, I have seen where you build an enclosure on top of the Voron and put your filament up there to feed it, and it acts as a dryer. I've seen that.
Yeah, that's a great idea. You use the hot end and the bed to equilibrate the enclosure's ambient temperature. It's beautiful.
Mhm.
That's actually really smart. I mean, you use less, you're reusing the energy, right? Sustainable.
Right, it's like a soft-looking lollipop.
Yeah, right.
But also, the S-Vols, that's something that's kind of got me. The S-Vol system, which I love that printer. I think it's great. Haven't had a chance to get my hands on one and try it yet. But I think that if you start in the realm of, sustainability, you're talking about a $300, roughly $300 to $400, depending on where you're at, direct drive, Prusa-like printer that is easy for somebody to use. It is sustainable because you can easily find the parts. That, to me, kind of sits in that their entire network sits in that kind of, I guess you could say, gray space.
Yeah, I think it's a good place to be, though. I mean, it's got the Super Penda Super Penda drive, or not drive, auto leveler. It's got a lot of the direct drive systems that we're looking for out of the standard Prusa, and I would say it's the intermediate made basic, right? Like it's easy for a beginner to understand now. So I think it makes sense to me. Like what we say it all the time: buy once, cry once.
Yeah,
It
exactly.
might be a little bit more expensive, but you're not going to be spending $100 to replace the bed, to replace the motherboard, to replace the motors eventually, to add a dual Z. You're not going to have to do all those things. A lot of these things are already on it. So I mean, they kind of beat you to the punch on that stuff. And I love that idea of buy quality, buy once, get the right item, make sure it's right, and then it only hurts the one time.
Yeah, definitely we want to get our hands on one of those, and I may eventually go ahead and get one, for us to review, and we could do a review on it on the blog, and write a review on it, and some of the other stuff, which I've been meaning to do that for the Voron. But just have not got around to doing it yet.
Come out with the Voron 3 next, and then
Oh, Jesus, don't even start me.
Coming up next.
Don't start me on other small little. I have other things I got to take care of first, like building this CNC machine, which that's also where you start getting into some fun stuff.
Oh yeah.
Which that's where you really start playing with the extruder, because if your layer lines are wrong, then guess what? You have no more structural rigidity.
Yeah, it's kind of scary in there. So I mean, there's a reason for there's a use for subtractive and a use for additive manufacturing. So I think that having a CNC machine is great too, because it's so easy to convert that to an engraver as well, which is, funny enough, a change of the extruder and hot end.
Right, exactly.
So, but yeah, no, we kind of got a little off topic there. I mean, honestly, extruders are so important though, that like I think I've had on each of the Ender 3s, they come with a plastic extruder, and it's a single gear. So you can tell, if you use it a little bit, you can immediately tell that it's maybe not pulling that plastic as strong. If you ever try to, there's a good test. This is something I should have probably said a lot sooner. This is something that my brother kind of showed me. It's a great idea. So if you take the Bowden tube off and you put that filament to the base of wherever your extruder is about to push out the filament, right? If it's a direct drive, I'm sorry, you can't really test this way. You'd have to do it a different way. But the whole point is you take the bolt and tube off, you put it to the end of where it's going to shoot out of the side of the extruder, and then you take a Sharpie and you mark a spot right where it lines up with the beginning of the extruder, and then you measure out 100 millimeters, and then make another mark on the Sharpie, and then tell the printer to extrude 100 millimeters, and I can guarantee you, even if I did it on each one of my printers now, it wouldn't be right. So those are the things I had to change, and we talked about the flow rate. That's a good, easy test for your flow rate, because then you could do some calculations. You can change some of your in Clipper it's called rotational distance. Um, I believe it is called flow rate in Marlin. So yeah, you can have a lot of control on those things. You can test to see if you're extruding 100 millimeters exactly.
I'm gonna have to try that one though, just to play with it.
It's very humbling. I'm not gonna lie.
It sounds like we may need to break out one of the spare enders in the other room and do a YouTube video on that, and a little tutorial, and show people how it works.
Yeah, that shouldn't be too bad. We could probably run it off of a small Pi or something like that too, or some small microcontroller. Shouldn't be too bad. Just hook all the steppers up and try to do the same push.
Right.
But no, yeah, that's the easy way to quickly test what your flow rate is, and I will remind you, not all brands are made the same.
Oh no.
They have different blends of plastics and polymers. Not all of PLA is the same. Not all PETG is the same. So just because it says the same thing on the front, the consistency and blend has to be proprietary to that maker, and because of that, that creates a lot of diversity in some of their filaments.
Yeah, and the thing is, like you said, the extruders themselves are not they're not all made equally. We know that for a fact. If you have the plastic extruder, I think I may have a spare one of those. That comes on the Ender 3s. Get rid of the darn thing quickly.
If it still lasts you, gee.
Yeah, right. Some people, man, they live and die by the sword. Okay.
Yeah.
So you never know what you're gonna get. But the thing is switch that thing out to metal. Should be the first upgrade you do. You shouldn't have to worry about it all too much. Because the thing is do it now and not worry about it later.
Yeah.
And that goes along with sustainability thing. Because the thing is, if you replace it now with a metal one that works, then you won't have to worry about doing it again later. Or just buy the printer that's got a metal one on it.
Yeah, if you buy it out of the gate, that's probably your best option too. I won't say that it's completely configured. You're still gonna have to calibrate and all that good stuff on it. But at the end of the day, yeah, I mean, we said it before: buy once, cry once. I stand by that. Get the metal one, get the dual gear, get the direct drive. It's gonna do you better, and you shouldn't have to replace it as often. But it is much more expensive. You really do pay for the quality.
Yeah, and that's the thing. That's what I've always stood for and stuff like that. It's also, it's the fact is that most of us are hitting that point in our lives where we pay for convenience. And stuff that works correctly is a convenience. Something I don't have to fight all the time is a convenience.
Yeah, right. It's something that's not throwing me errors all the time, and I have to fix.
That sounds all familiar, just not with the 3D printer.
Yeah. we won't call anybody out.
Yeah,
if you're doing the same thing over and over, and you don't think that you're crazy, I got some news for you.
Right. Definition of insanity is, it is very well documented.
It's true. All right. Well, that's good though. We talked about the basics. Like we pinned. I mean, those are the main things I think about when I'm thinking about a FFF or FDM printer.
Mm-hmm.
I mean, you don't have the same thing when you talk about SLA or DOP. The resin printing isn't the same kind of extrusion. You don't have the same thing for a powder bed fusion print. That's completely different. However, you can have the same thing for pellet fed.
Now,
There are pellet fed extruders.
that makes me actually ask this question. Because I don't know why it just hit me. But if you're doing the powder bed fusion, right? Wouldn't the laser be considered an extruder technically?
Oh. I guess I would count it as a hot end, but I mean, but only in the sense that it's not touching um, the material it's printing of.
Mm-hmm.
There's got to be something that drops the powder on the bed.
There's that little stick thing that spreads it. So I think that would be considered an extruder.
I guess in that sense I would count that, because like it's got to distribute the aluminum flakes or whatever alloy you're using evenly, and yeah.
So it's kind of like the autofill system on a resin printer.
Yeah, I would count that.
Just an idea.
Count that. Actually, that's a good point. Form Labs has a 3L that has a cartridge-based resin. So it's like kind of like your standard 2D printer that you have in every office, where you load a cartridge and it pulls from that cartridge. In that sense, the mechanism that's pulling from the cartridge and bringing it to the print bed is an extruder to me.
Yeah, me too. It meets the definition.
Yeah, I mean, we don't have to necessarily call it an extruder, but it's doing the same process. I can tell you that much.
Yeah.
But we can even get weirder than that,
Oh,
right?
boy.
So yeah, we've gone down the Google rabbit hole several times to see just how many printers are there, how many extruders are there, what can you do.
Then you see them in person, you realize that wasn't just as weird as you wrote.
No, we're definitely it gets bigger. I was skeptical when I first saw about the hang robot. You hang it on pulley points on the corners of your room so that your room is your print bed. That right there started a rabbit hole that I haven't even found the bottom of yet. So
Pandora's box.
Yeah, right. So I'm curious, but we found a few things. We found, I think one of the things that we constantly we laugh about, and we say we want to get one of, is the pancake bot. We bring it up a lot, actually. You could put in a whole bunch of models of hey, I want a pancake of Marilyn Monroe, and it'll put that on there, and it will. The print bed is a griddle, it's hilarious, and then the hot end and extruder all together is like a
plastic water, like a plastic bottle.
Yeah, it's crazy, and even deeper than that. So that's a food situation. So that right there, that's amazing.
Yeah. There's also the shock now. The thing is we were talking about food. I'm fat, but I was doing a little bit of research because that pancake bot, man, that'll send you down a rabbit hole that you don't really want to go down, because you never know what you're going to find at the bottom of it. There's people actually 3D printing chocolate.
Oh yeah.
In the same process, they're 3D printing chocolate. They're 3D printing, candy or hard, I guess you could say, what is it?
They've got crystalline lattices and things like hard candies and stuff that you can make.
So you're actually 3D printing with molten sugar.
Yeah, and honestly, the same way that they figured out how resin printing works. And when I say they, it's like a general they. Like we figure it out by, experimenting with it. They had a whole bunch of different types of ingredients for, sugars and candies, and you can, just start letting it do its thing. However, I'm not going to be the first one to taste test it.
But you would have pancake bot though.
It's different. That's different. No, I'm skeptical on the pancake bot. You're not wrong. The next thing, it even gets deeper than that, is they're 3D printing meat. Now that's one that's a little bit questionable so far. Yeah, they're doing this, but you think about it. What was it, 5-10 years ago? McDonald's caught a lot of flack because they were caught, or at least it was shown that their nuggets were pink paste that they put, you know what I'm saying?
They spread out. Yeah,
extrude out. But no, they can just as easily make that into have this thing that extrudes it. A printer and make those nuggets. Now, I'm not saying that's what they should do, or I'm not saying that's what they are doing.
Design
I'm
your own
just
nugget.
saying how easy, like from that process over. Yeah, and of course, how does that make it a nugget? It's only pink because it was spray painted and or dyed. You don't want to see the actual color.
We're not going to be. We're actually now going to be starting to 3D print hot dogs.
Yeah, so if anybody wants to hit us up at printed hot dogs, we got a food truck coming to you.
Design your own nugget.
Yeah, there you go. Exactly. Now you get to keep this nugget. But no, that's serious. I mean, not a lot of people are doing it, but we're talking sustainability. Of course, the population is growing, which means we need more food, and it's ever growing more food. We figured out a whole bunch of ways to kind of create a lot of livestock and stuff like that. This is a way that I bet you this guy's vegan. How he wanted to solve the meat problem, right?
Yeah, more than likely.
So I mean, he might not be. However, I think we're not there just yet on that side. It's going to take a lot of convincing, and kind of, I guess, necessity for us to jump on that train. But there's people eating the chocolate. There's people eating the pancakes like it's going out of style.
The good thing about that, though, I'll say this, is it's getting kids involved.
Oh yeah.
It's getting kids involved in 3D printing. It's getting people involved in additive manufacturing to an extent. You may not think it's additive manufacturing. Here's a shock face. It actually is, because you're adding to. So the thing is anything you could do to get kids and people involved in the AM industry, it is, I think, a win. And anytime we can get a kid says, hey, you know what, I saw, a friend or somebody's dad or somebody's mom or somebody bought a pancake bot, and now I'm interested in engineering.
Oh yeah.
We win that battle.
Oh yeah. I if you showed me the pancake bot when I was in school, I would not leave you alone about it. I would ask you to make. I'm like, there's no way that that thing can make this look like this person, and I would go and get more photorealistic pictures continuously until I got something that was like, that's not good. And then by that point, I'm improving the printer. So like, exactly, it's something that's beneficial. I mean, there's another piece too. We've talked about it before, and I think we talked about it very early on in the 3D printing conversations.
Mm-hmm.
So they're building full homes with 3D printers, right?
Yep.
So they're extruding concrete, similar to how the pancake bot works too. It's following a set pattern that's G code, and it's extruding out a consistent concrete paste that's drying as it goes. You can put drywall up around it. It insulates. Like, there's so much that it solves for, as far as a home building and a construction standpoint, that like if we're consistently building houses with these products, then I think we can double the capacity of our homes, and maybe we could bring down the housing market a little bit and make it affordable for everyone, right?
I think 3D printed concrete, that industry is going to boom probably here in the next couple of years. And the reason why is Lennar Homes, who built mine, is partnered with some of these companies building 3D printed neighborhoods, and parts of Florida and stuff like that. They're also using them to print tiny homes for veterans who are displaced. But the thing is they're also going to build a type of concrete formula. They're working on it currently that will be used to print locations on faraway planets like Mars and the Moon, and use the material that's there to create the grit and stuff like that to print these things. Meaning that eventually we can do the same thing here in the U.S. Throughout the United States, throughout the entire world, to 3D print dwellings from local materials, sustainable materials, turn that into concrete and clay, and build houses. So then everybody has house. There is no housing crisis anymore. These concrete 3D printers, the biggest question that I have is, I would like to do more research on the current material they use to make sure that it matches the fire retardant specifications that are required. That the seismic material can be handled right. Because of the lateral shift, and so you don't have a layer separation, because a layer separation in a 2-story home is a little bit more than a layer separation in 3D print.
Oh yeah.
A little more dangerous.
I don't want to be on the second story when that happens.
But the thing is I think that and the thing is if you're for or against, they are using these 3D printers in the war in Ukraine. They had them in Kiev, where they were 3D printing tank tracks to stop the oncoming onslaught of the tanks when they're coming down Route 31 to Kiev. These printers are showing their worth. They're using them to protect roads, protect infrastructure, build that stuff up. And also people are using them to start businesses, different businesses. You're building sheds. You're building, like we were talking about earlier, dog houses.
Exactly. There's a lot of options and a lot of things that you can use them for. I think that's one of the fastest growing, I think, initiatives. We looked at, there's some research going on in a multitude of different countries. Australia, there's a few initiatives to kind of try to save the coral reef out there, right? So they're 3D printing stuff for that. But I think at the end of the day, they're using similar ways to print it, because that's more of a ceramic and concrete to us. Like, those building blocks are so necessary to creating an ecosystem, creating a city, a village, bringing more people to whatever your main goal is. So I would be real surprised if come 5-10 years from now that full neighborhoods aren't built in like 2 to 3 weeks with a 3D printer.
That makes sense. I can agree with that.
So,
I hope to see that. I would be involved in it too.
It would be really cool. I think that just making one, it would be really fantastic. But yeah, no, you bring up a good point. I think one of the biggest worries that I had when I first started printing is I was printing in PLA. I was like, oh, this feels like it'll break. It feels very brittle after my print, and in a lot of cases I broke some prints. And then when I got to PETG, it's a little bit more resistant to the bend, a little bit more resistant to some of the impacts it has, and then it steps on up. So my thing is that I don't think that they're inherently using poor concrete or mixtures or anything like that. But when you build anything and you don't consider seismic activity, you get what happens in China around the last, I think it was the World Cup, a couple World Cups ago, where there was an earthquake that leveled the whole city.
Yeah.
You shouldn't have that happen. It should be able to withstand up to 6.0 hurricane magnitudes, and that should be baseline from the start. You should build it to prepare for the worst, as opposed to trying to upgrade to fix a new problem.
Right. I can see that.
Yeah.
And I know you're getting ready to bring up one of the other ones that we are thoroughly interested in, because I know that's kind of where you're going with us.
No. You go ahead.
You talking about the pellet extruder? Oh
yeah. Okay. Maybe I have 2 more. So yeah, the pellet extruder is good. We watched not Impossible Builds. I'm sorry, they have a giant printer, but it's not pellet fed. There's, what was it? Dimension something.
Dimension or something like that.
Something Colossal Dimensions or something similar like that. It was Dr. D-Flow was the YouTuber that was creating this giant. Man, this is like the size of half of a single car garage bay. Like, it's a giant printer, but it's using pellets. He has to bring pellets in on with a forklift. It's on a pallet, like it's crazy. So, but with that, we saw a few of them at Rapid when we went last year. There is like of course, a container that you put them in, and it has a type of vacuum system to pull from that tube or that container and infeed to the extruder. Those pellets just sit on top of each other until it heats up enough that they get melted in. And that is honestly one of the best ways, because if you drop any of the, or if you mess up any of the prints, you can really put that filament, like if you get it back down into its pellet form or break it down into pellets again, you could just toss it back into the system again, right?
Exactly.
And keep it rolling. I mean, it's something that's very sustainable in that sense. He went through some of the drawbacks that I would see. Of course, if there's a clog, what do I have to release that clog? If there's any flow issues or hose, like if there's like a leak in pressure, air pressure, then you'll have some issues. But a lot of those things like can be fixed easily with something that's automated sensor, right? Maybe some MQTT setup, and it tells you, hey, you've got a loss in pressure of the system, and you need to check the hose or something like that. That can all be built in. However, the fact that people are using these industrial-sized extruders that feed pellets, it opens up a whole new world. I mean, we saw filament-fed extruders or hot ends / extruders as all direct drive all together that you load onto the top of a KUKA robot arm or an ABB robot arm, and it goes from there. Of course, you have to have some type of extruder or infeed into that hot end or that tool head, I should say, because it's a direct drive. That's everything.
Yeah,
right? I guess would it still be called a direct drive? I mean, it's a vacuum tube, right? There's nothing driving it besides vacuum. So
well, technically, vacuum's a force.
yeah, I mean, I guess I would count that then.
But we're getting all into physics and math and shit now.
Yeah.
We'll see what our podcast does go against different aspects of the industry. But I'll tell you one thing: there's nothing cooler than those pellet fed extruders. We also saw them on Creality on the Ender 3s. Remember that?
Oh yeah, we saw one on the Chiron too.
Right. There's also companies out there that it's a open pellet extruder, so you can build it yourself instead of having to go through something else. So it's a complete open source, 3D printed and designed pellet extruder that goes on these printers. The funny part is the cost per pound of the pellets themselves is drastically less than what you're going to have to buy when it comes down to rolled filament.
Wow. Why do you think that is? You think it's just because it's easier to make the pellets than it is to spool up a filament roll?
Well, I think what they do is that they use the pellets to create the filament rolls. So it's prior to right. It's pretty much here. Let's bag this and give it to you. And also, most filament that's in the bag form for the pellets is not colored. So you have to get the colored pellets to make the change happen.
You got to get that's a good point. That's a great point. It's not like you put all of one, like if you want a yellow item, you don't put all of yellow pellets in there. You'll have white pellets, but you add like so many pellets per, area, right?
Mm-hmm.
And it makes it that color, it makes it that style, right?
Exactly. And I think that the pellet extruders are actually extremely sustainable. Like you said, if something breaks or something happens, you can just recycle it and start it all over again. Yeah. And the fact that people are buying thousands of pounds of these things for that, and we're also recycling robot arms.
Yeah, that's a good point. That's good, because the robot arm was definitely used for something else, as a pick and place robot, or
right,
or it was building something. Maybe it was welding.
Mm-hmm.
But now it's printing.
Yep.
It's creating.
Exactly.
So there's another. I guess this is more of a hot end. I was gonna bring up the Stargate.
Yes.
So yeah, we haven't talked about them in a little bit.
Yeah.
But they're still doing big things. I mean, they launched the Terran 1, even though it failed second stage. It still was a successful launch. I mean, honestly, it did what they needed it to do. They got past
Max Q.
Max Q, which is very impressive. I have never been past Max Q, so
Yeah, neither have I.
so not an easy feat to do. But yeah, these guys are crazy. Their extruder is more of a I guess
MIG welder.
Yeah, it's like they're pretty much welding and calling it 3D printing.
Yeah,
right.
It's a MIG welder on the end of a robot arm.
Yeah, it's so precise though. It's a beautiful thing to see. I mean, you can see the layer lines just like it would be a normal like FDM print at your house. So it's crazy that that's something that has been launched into space and maintained structure as it did.
And the thing is, they want to ship these Stargates. Their main goal in life is to ship these Stargates to Mars and build rockets to launch from Mars to move on to other bigger, better things. That's one of their end states, is to use these Stargates to be rapidly portable, to be able to build them up, package them up, stick them on a rocket, and launch it. Yeah, me too. I don't know where the heck I'd put it, but we figured out after that.
Yeah, we'll figure it out. I'll make it work.
That's one of those questions: is do you run on regular 480 or do you require a little bit more voltage?
Yeah, I got my own generator in the back for a special reason.
But it's just one of those things. But the thing is, that you think about, they're gonna take this 3D printer, shove it into a box, shove that box into a rocket, or into a tube, and then launch said tube to orbit, and build another rocket on another planet to launch it from there.
It's just going to keep going.
Right. It's like,
it's actually a great initiative.
And the thing is, if you think about it, the fuel that they use on board the rocket is methane. It's a methane rocket. You can find methane in most places.
And if we make it to Mars, I mean, you probably clear out the methane there.
Yeah, pretty quickly.
Wow. But yeah, no, I mean, honestly, if you considering all these things, we've got specialty extruders, we've got if you break it down, most people are going to be with a Bowden tube. Yeah. There's nothing wrong with a Bowden tube.
Oh, no, definitely not.
I mean, tried and true. You think about it, I still always have my everyday shoes, but sometimes if I need to, I got to put some boots on to do a little bit more of an industrial job or get a little bit dirtier. However, do I prefer the boots on all the time? No. Some people do, yeah, but not everybody. So, I mean, I think the case is what you're printing should dictate pretty much what your extruder needs to be. But if you've done the research on what the bare minimums are, then yeah, have at it. I mean, the only way that you can learn is to try it, right?
Exactly. It's give it a shot, see what happens, go from there.
Oh, yeah.
So I think we've hit all of our major wickets.
I can't think of any other extruders, to be honest with you. Maybe next week I'll come back and have another one for you. But I think
because I know when we were talking about a printer type, that I don't know if it has a special extruder on board, but I don't think it does. It's just a direct drive.
The Deltas.
The Deltas, yeah.
I think the Delta is a direct drive as well. But I'd have to look at that. Maybe it is. Okay, yeah, that makes sense.
Weird printer.
The Bowden tube system, it's weird. It's got a crazy tri-wheel or tri-arm system going that it confuses me, but it works somehow.
Yeah, it's a giant spider.
Yeah, it's crazy. It's beautiful. A lot of companies have figured it out. If you have any time, check out Orbital Composites or the Orbital E robot, the Orbital S robot. Those things are crazy. And the Orbital S is kind of it has one of the KUKA robots is controlling the bed, so it can move in 3 directions. And then you've got an arm that's the extruder, so it can move in 3 directions. You get so much more exact prints, and you don't need supports anymore.
Yeah, well,
that's pretty cool.
that's something, I'm telling you. And
Yeah.
it's really cool. And, there's so many things you can do, so many different printer types. And, that's stuff that we like to play around. We like to look into, do some research into, learn more about. So if you know of any weird or, what we consider weird, or interesting things, send it to us. We want to take a look. We're kind of curious. If you send us down a rabbit hole, then hey, you win. We'll have you on the podcast with us, and we'll talk about that said rabbit hole. The rabbit hole of finding things. We may hopefully start you on a rabbit hole.
Yeah, I get told I need to close out my tabs in Chrome because somebody says something, and I've got 50 tabs open now. And I'm like, well, because that relates to this, that relates to this. I need to save everything.
Yeah, I can see that.
Every time.
And, so I will say this. I think we've hit all our major wickets, and I just want to say thank you. I think we've, kind of officially, crossed over. And to, I think too much information at this point, I think we're getting into, but I don't think we're ever going to get to that. If we do, I don't think we were in the right business. But, I'm just looking at the numbers now. 1,881 all-time downloads. Y'all freaking, we're killing it. I know some people says, oh, that's not a lot. Yeah, for us it is. 52 in the last 30 days, extremely happy with that. Yeah, I know. Me too.
Yeah,
and exactly. And, the thing is I couldn't tell you, I look forward to these days where we can record some fun stuff for you, learn something, hopefully you guys will learn something. We hope to, get moving with some of our stuff with some of the other smaller companies. You did hear some company spotlights before with Ulindo. And we hope to play around some of the Ulindo stuff. So, hopefully we'll get our hands on that soon here in a little bit. But again, I just want to say thank you. Thank you for everybody who's listening. Send us some ideas. Let us know what you're thinking. Let us know if you find anything fun or interesting that you want us to take a look at or possibly try, or even a new filament type we'll take a look at. Let us know. So, I just want to say thank you, and I'll turn it over to John.
Yeah, so, same thing as Nick here. I always got to echo these guys because, I'm very grateful, very, very grateful. It's nice to have a platform to speak. And to be honest with you, if anybody has anything that they want to kind of discuss, or if they have anything they want to fact check us on, even I welcome it. I would love to learn what I don't know already, because of course we don't know what we don't know. So the only way that you can learn that is by learning and by doing. So honestly, it's kind of one of our goals each and every time we even look at a computer is I'm Googling something to learn. So if you guys have any topics that you guys kind of want us to cover as well, we can break it down into a series. We can have a video, maybe we can explain some things. I kind of like the idea that Ed pitched to me a few weeks ago, where we discussed some of the physics of some of these interactions that printers have. Why does the filament melt this way, or why does why is the filament stick to the bed where I can't take it off? Stuff like a lot of those questions that kind of break down into not just chemistry but physics as well. I'd like to start kind of going over those. That sounds fun. So if you got anything like that you want to learn about, reach out, and we'll kind of add it to the list. I've already got quite a few in there, and it'll keep building, and that'll be coming soon. So stay tuned, guys. Same thing as we said earlier. Check out Printed Heritage. We're kind of taking everybody's feedback. If you've got an issue, let us know. We'll work on it ASAP. And if you've got any questions, reach out. So other than that, guys, I'm very appreciative, and stay tuned for more. Thanks.
All right, y'all. Have a good one.
That's all for this episode of Tech at Lunch. Thanks for tuning in and joining us for this tech-filled lunch break. We hope you enjoy the show, and don't forget to subscribe on all channels. And also, you can find us on YouTube under Vulcanar Technology Solutions. And join us for our next episode, which gets published every Wednesday at 8 a.m. All right, y'all. Have a good one. See you later.